Good morning, friends. Bayes theorem will be the topic which I am going to take today. Before we do that, we must understand theorem of total probability. So here are my notes on that. Firstly, we will discuss this, then we will come to this Bayes theorem. This is theorem of total probability. So before we switch over to Bayes theorem, let us try to understand number one, partition of sample space. This is the sample space, and these are events. They are mutually exclusive events. Since E1, E2, E3, En are n mutually exclusive and exhaustive events. That is, this complete S comprises E1, union E2, union E3, union En. They are all mutually exclusive events. So this is the sample space. Now, here is the event A. This we want to find out event A. It will be this portion plus this portion plus this portion and so on up to this. That is, A will be equal to A intersection E1, union A intersection E2, union A intersection E3, union A intersection En. So probability of A will be probability of E1 multiplied with probability of A when E1 has already occurred, plus probability of E2 into probability of A when E2 has already occurred. So we'll apply this, and you will find that this probability of A, which is sum of all these, is called the total probability. So total probability means probability of A, and Ei and Ej, since they are mutually exclusive, their intersection is phi. Now let us switch over to the Bayes theorem. If E1, E2, E3, En are n non-empty events which constitute the sample space, look here, E1, E2, E3, so on up to En, they constitute the sample space. And this is the event A. A is any event of non-zero. So A will be equal to A intersection S. Complete is S, and this is A. So A intersection S will comprise of this, and so on. So A intersection S will be A intersection E1, union E2, union E3, union En. So it will become A intersection E1, union A intersection E2, union A intersection E3, so on up to A intersection En. So this is A. Now, probability of Ei, that is this. Probability of Ei is when A has already taken place, will be A niche, probability of A will be in the denominator. And in the numerator, there are always intersections. So, probability of A intersection Ei over probability of A can be written as probability of Ei into probability of A when Ei has already occurred. So, from here, probability of Ei when A has occurred can be written as probability of Ei into probability of A when Ei has already occurred over sum of the probabilities, that is total probability, has to be written here. And this is sum of all these. Sigma PEI into PA when EI has already occurred, or EJ. They have already occurred. J goes from 1 to n. So this is the Bayes theorem. Now, how to calculate probability with the help of Bayes theorem? This is the topic. So, let us take an example of 3-coin case. When 3 coins are thrown once or 1 coin is thrown 3 times. The sample space is like this. This is 3-coin space. Now, how we will apply the Bayes theorem for this case? Now, let us take one example on Bayes theorem. It is a total fun. Look here. There are 2 bags here. Bag number 1, bag number 2. Bag number 1 contains 3 red and 4 black balls. Bag number 2 contains 3 red and 6 black balls. So, this is bag number 1, B1. This is bag number 2, B2. These cameras are there. Look here. These are video cameras. There is a boy, Ramu. His friend is helping him. His eyes are closed by putting a strip on his eyes, and he is walking as a blind person. To help him go inside this, and in the adjoining room, you find there are many students here. There's a TV screen here. Whatever is happening in this room is being observed by the students. And these students are going for a bet. And the bet is whether he will go to bag number 1 or he will go to bag number 2. Some students say he will firstly go to bag number 2. Some students know he will go to bag number 1. Now, since he is working, he is behaving like a blind person, so he doesn't know which bag is where. Now, how to attempt the question like this? Probability of E1 is half. There is 50% chance he will go to bag number 1 or bag number 2. So, this is PE1, this is 1 by 2, 50%. PE2, this is 50%. Now, when he has gone inside, he has brought a ball. So, it is red in color. So, probability of red is 3 by 7 here. And probability of black is this. Probability of red is 5 by 11. And probability of black is 6 by 11. So, when he comes out and he is brought to the other room and he says he has brought this ball. Now, it is a red one. What is the probability that it is a red one drawn from bag number 2? So, it is like this. Half into probability of this red, that is 3 by 7, plus half multiplied with 5 by 11. This is the total probability. So, and he has brought it from bag number 2. This is the expectation. This is the probability. This is half into 5 by 11. We get 35 by 68. This is how we will be calculating the probability with the help of Bayes theorem. Thank you. God bless you. Bye.